I'd like to take this opportunity to thank Fuels and Lubes team to give this platform to share the Chrysler oxidation and deposit test. Also, an apology from Chrysler for not being able to be here for this presentation. But at the same time, I would like to thank the entire development team who has been working on this effort for the last 2 years and over to bring this test to the category. So with that, I'd like to quickly touch upon the key areas that I will go with in this presentation. I'll give you a little bit of background of the objectives that are required to qualify a test and be ready for the upcoming category. The test procedure details, the reference oils, how they play a critical role. We'll talk about the key areas of oxidation and deposit test that is required to demonstrate performance, whether it's a % P-vis increase or weighted piston deposit from a deposit standpoint, running the newer low viscosity oil, 0W16, and also some data around phosphorus retention. At the end of the deck, we'll also share a little bit about the field test correlation with some of the Chrysler field test work that has been done in Vegas, and we'll conclude with a summary. One of the things, before I get into the Chrysler oxidation deposit test, I think our speaker, Terry Kowalski, yesterday talked about the GF6 category as a whole. It's an exciting time. There's lots of new tests coming to the category. But before we get into the test development, I mean, if you go back 3 years, it's nice to sit down and understand how this category has evolved, how the specifications have evolved over a period of time. All specifications have been evolving. It's getting updated with newer hardware based on the needs demonstrated by and required by the OEMs. Typically, those demonstrations are done either through a replacement test or a newer test. The starburst and the donut symbols provide consumers with the right information to use the right oils in those engines. And if you look at the snapshot of this on this slide, it just tells you that the key areas that we have been looking in for the last couple of decades has been oxidation deposit, wear, sludge, fuel economy, corrosion. And if you look at some of these tests that have been carrying that load, has stayed and lived through a lot of that period. So standing here in this juncture, we are in exciting times where going forward, we will not only be carrying some of these tests as it is with newer hardware, but at the same time, we'll be adding newer tests. Like my previous speaker, Angela, she talked about LSPI. So there is a paradigm shift. We are addressing new tests, and we are bringing in those new performance to be evaluated with the oils. So overall, it's a challenging time. It's a great time to be in this industry and move forward the performance attributes to eventually bring it to the consumers. So with that, I'll touch upon the key objectives that are typically required to demonstrate performance. And in this case, Chrysler's oxidation and deposit test, we went through a couple of checklists. Basically, in this case, we went through, for an oxidation deposit test, you have to demonstrate wetted piston deposit performance, kinematic viscosity increase through a % viscosity increase, P-vis number, demonstration to some real world through field test, focus on oxidation performance, and also backwards compatibility or correlation to the previous category. So that's always an issue that we have to address as an industry. And I think I heard a question yesterday about just a quick snapshot on the final test procedure. The final test procedure will run at about 3,900 RPM to 50 Newton meter of torque. The intake air temperature is about 35 degrees C. And after multitude of testing, the ring gap that the team settled on was 25 by 35 thousandths of an inch. Now, what you also see is to understand how Chrysler's oxidation and deposit test rank compared to 3F and 3G, the current test or the previous test, in different performance areas. If I quickly take you through, the initial oil charge is very similar between 3G and Chrysler. The oil temp is also very similar in terms of both the test. The duration in this case, 3G is 100 hours based on the GF5 limits. In case of Chrysler, based on multitude of development work, the test length was selected to be 90 hours, and you will see some of the charts that we will show in subsequent slides. Blow-by is a little higher compared to 3G, but again, the blow-by was determined based on the ring gaps work that was done. There was a lot of testing that was done to settle on that ring gap and to also have a certain blow-by that is required for the test. Oil consumption, if I compare to 3G, it's very low in comparison. And one of the things that we also touched upon is the total oil addition. If you compare the oil addition in Chrysler oxidation and deposit test versus the 3G, it's very low because of the Chrysler engine. You can run the entire test on a full charge, which basically is due to the reduced volatility effect that the test has. And I'll touch upon that in a couple of slides. But this gives you a quick snapshot and comparison on the test procedure between 3G and the Chrysler oxidation and deposit test. Reference oil. So we talked about procedure. One of the key things is also the selection of the right reference oils. And when we select reference oils in developing a test, we got to keep a couple of things in mind. And if you look at the selection of reference oil, the first studies are usually done with existing reference oils that is used in the 3G. And here we have a snapshot of 3 reference oil, TMC 434, 435, and 438. And if you go back and look at it, the oils were designed to basically have a certain discrimination in certain areas. In this case, if you look at 434, you have a borderline PVS and WPD, whereas if you look at 438, you have a failing WPD, and 435 with a borderline PVS and failing WPD. So basically what you're looking for is with 2 oils, you're looking at that separation. Can the test discriminate oils for that to meet that performance? So that's one of the criteria that you look at. The other is when you develop a test, you also want an oil that is sensitive to your test severity, so that as the test ages, the severity can be picked up with a certain reference oil. The other 2 oils, REO2 and REO3, are the new oils that will be introduced, that was used in the development process. REO2 is TMC 436, which will be used by Chrysler in the precision matrix. And this was, bulk of the development was done with REO2, which again is a passing 3G oil, but also has field test correlation with Chrysler's field test data set. The REO3 was picked up as a very robust oil in terms of PVS performance as well as weighted piston deposit performance, again, to basically show that there is a discrimination between the oils for this test. So this gives you a snapshot. What I would show you in the next subsequent slide is a bulk of data set around 434 and REO2 with some data set in REO3 to basically show how the test was developed based on these technologies, meeting backwards compatibility, discrimination, repeatability, and reproducibility. So here is a typical curve. If you have run sequence 3, you would be very familiar with this picture. On the x-axis, you see test length, and on the y-axis, you see percent viscosity increase. And what you're seeing is, as the oil degrades, you basically have a percent viscosity increase, and based on a certain limit, you determine whether it's a failing or a passing oil or a robust passing oil. If you look at now the 3 reference oils that I talked about, TMC 434, REO2, and REO3, one of the things that you're looking at is, can this test discriminate? And if you look at the 3 clusters, you clearly see discrimination between these 3 oils from a percent PVS standpoint. Again, this deck doesn't have a whole lot of statistical analysis, but there is a humongous amount of statistical analysis that was done on these data set and was presented to the industry and is also continuously getting updated as we speak. But overall, you demonstrated that the 3 reference oils picked can provide you discrimination in percent PVS. This is a quick snapshot. The other thing that you look at is when you are developing a test for the category, you just don't run it in one lab. You have a multitude of labs that come and contribute to the precision matrix. So one of the things that you have to look at is repeatability as well as reproducibility. So if you look at data set, the cluster of data points, it gives you a snapshot of the 4 labs that contributed to this data set as of a couple of days back in terms of performance. And if I look at the reference oils, if I pick Southwest Research Institute, if I look at the REO2 data set, both the WPD and PVIS numbers look very tight. And same is for 434-1 in terms of WPD and PVIS. But at the same time, we need to make sure that we understand if there is a lab which is severe or milder before the test goes into the industry precision matrix so that we can minimize any of those issues before that. Again, this is an eye chart, but what I wanted to just touch upon is the demonstration of the WPD separation. And again, if you looked at the description of the oils on my first couple of slides, you don't have one oil that meets both WPD and percent PVIS discrimination at once. So you have certain oils that are designed to do certain things. And in this case, if you look at 434, REO2, and REO3, in case of WPD, 434 and REO2 doesn't have that statistical difference in WPD, but then if you bring in an REO3, there is a statistical difference between REO3 and 434 REO2 in terms of WPD difference. And again, this has been demonstrated with an extensive amount of statistical work, which can be a presentation of its own. The other thing that we are going through in terms of GF6 is demonstration of ultra-low viscosity. One of the things that we have to make sure that the test is able to run a 0W16 oil before even entering the precision matrix. And what it shows is the same technology, that is REO3, and you see 5W20 and 5W30 and also 0W16. So you see 3 different viscosity grades and its performance from a percent viscosity standpoint, PVIS standpoint for this test, and the ability to run this test and be able to demonstrate that to the industry. Another thing that we also have to look at is phosphorus retention. And again, the phosphorus retention data looks very comparable to current 3G for all the reference oils, 434 to REO3. So one of the things that the industry has asked the test development team and also the task force team is to demonstrate the severity that and compare that to sequence 3G. So a lot of work has been done to basically go through this, the severity differences between the tests as it is right now for the Chrysler 3H, Chrysler oxidation and deposit test development, and also the current 3G. So what I would like to take you through is, let's start from the bottom. When you have a very robust oil like an REO3, your precision becomes very tight. If you have a very robust oil, it always passes, and you maintain that precision. And that's what is demonstrated here. You have a very robust data point which sticks together very well. As you start going to the borderline performance, as you lower your performance, in this case, you are moving up in percent viscosity, as is demonstrated by REO2, your data sets start to lose that statistical perspective. So your data is more wider because you are more closer to the borderline performance. And if you look at 434 again, and then if I look at 434, which is a 3G borderline PVIS oil, you have that spread of data point. But it is important when you're developing a test to have that oil, because if I'm developing a test, I actually don't learn much from this oil because it's going to always pass. So how is it going to respond to all the changes that I'm going to make to eventually settle down on a procedure? So a lot of the times, these are the oils that give you that that signal or the information in terms of test severity throughout the life cycle of the test, as well as when you're making changes to the development during the development process. But you will expect that spread. So from a statistical standpoint, you will expect that spread. And what this black line does, it basically superimposes the 3G acceptance band for that reference oil, because 434 is a reference oil that is used in 3G. And similarly, 435 and 438, you see the same spread. But again, the focus has been on these three oils during the development process. But I wanted to give you that idea of how the data and the severity is compared and how the selection of oils helps you during the development process. Now, if I do the same thing with WPD, it's a little bit of a different story. WPD, again, when you have a robust oil, you got a very high WPD. 7 is a very high number for folks who know what 3G and the oxidation and deposit test means. But as you come closer to the borderline, which is the current 3G limit, you have, again, that spread. But at the same time, in this case, we didn't see discrimination between 434 and REO2, whereas the discrimination was demonstrated by REO3 and 434. So again, the discrimination is there, and that's why it might not be on the same oil, but it's on a different oil. But you just have to make sure. That's why you have a multitude of oils to meet all the different performance criteria. Okay. So one of the things that is different between 3G and Chrysler oxidation and deposit test is the Chrysler oxidation and deposit test has a reduced volatility. Now, typically the idea is whatever ranking you have with the reference oils on your previous test, the industry expects that you might have the same ranking going forward. And in a lot of cases, when you look at these engines, and as we update the specification as of today, we are updating it to a newer hardware. So, a 90s platform has been changed to 2015, 16 platforms. So one of the things we saw is the Chrysler V6 engine has very reduced volatility, so it doesn't rank the oils exactly the way it is when you look at the data just as it is from the sequence 3G. So we went back and we went through the literature and we found a paper published by Oronite where they actually looked at the 3G curve from the 3G data set for some of their oils. And they estimated that by assuming percent viscosity increase in earlier hours, probably due to volatility alone, and basically what they did was they extrapolated linearly to 1,000 hours to demonstrate how much of that is the PVIS increases due to volatility and how much of it is oxidation. And if you look at it, the bulk of the increase is due to volatility rather than oxidation. And in case of Chrysler oxidation and deposit test, you see more of a PVIS increase through oxidation versus the volatility. And you can also pick that up the way the PVIS curve breaks down. In my previous chart, what I didn't touch upon is if you look at the curve, you have a very flat line, and once the oil degrades, it just spikes up. So that's another indication that you have minimal volatility into the system. So then what we did was, so I'll come back to this. But what we did was we corrected with the 3G percent vis data. We applied the same theory, and we replotted the data set. And if you look at the data set, you can basically, this green dashes are the 3G data, and they basically rank and after the percent PVIS correction. And if you look at the subsequent Chrysler oxidation and deposit performance for that reference oil, it basically ranks in the same fashion for percent PVIS. So there has to be a correction factor for volatility when we looked at the reference oils from sequence 3G. And the same thing we did for WPD, and we got the same results. So percent PVIS increase, correction for that volatility provided you that data point. The other thing we also looked at is the calcium accumulation. In case of, again, as I said, if you look at the calcium accumulation, which is an indication of how much volatility you are injecting in the system, and if you compare the reference oils, you look at Chrysler's data set versus the Sequence 3G, you see that difference across the board. In some cases, it's higher, in some cases, it's lower, but you see that difference. And again, it subsequently confirms that there is a reduced volatility effect with the Chrysler oxidation and deposit test. This is the last part of my presentation, and which touches upon the field test correlation. So one of the things that that the industry looks for is some meaningful correlation. And the way Chrysler demonstrated this was through a field test. In this case, the Chrysler's Vegas field test ran for 100,000 miles, covering 2 summers. The drain intervals about 8,000 miles. The engine is the same engine that has been used for Chrysler oxidation and deposit test, and the 2 oils that were used in that test was REO2 and REO3, on which the development work was also done. Here's a quick snapshot of the key used oil parameters that is of interest from an oxidation and deposit standpoint. If you look at the kinematic viscosity growth, you have very minimal. It's still within the guidelines. And also for oxidation as well as nitration, it's pretty much within the guidelines of the Chrysler's need. So it basically gave us that information from a field test performance. Same with another oil, REO3. And REO3, as I said, it has 3 different versions. You have the low viscosity version as well as the high viscosity version, the 5W20. And again, across the board, we didn't see any surprises for viscosity as well as the oxidation and nitration data set. It's all within the UOA guidelines, the used oil analysis guidelines. So with that, I would like to come to the end of my talk. What the development team and Chrysler demonstrated to the industry is that the test is repeatable, reproducible, discriminates on percent PVIS and WPD, and also has a real-world correlation with the field test performance. And this is kind of a snapshot of the checklist that the development team went through. As I said, stand-to-stand repeatability, discrimination, viability by running ultra-low viscosity, the future low viscosity grades, field correlation with the REO2-3, the final procedure being defined, the hardware availability, and also making sure the long-term engine supply, because eventually, if you looked at the second slide, when you look at a category, some of these tests live through for a couple of years, so long-term engine supply is of high importance. And finally, the lab-to-lab reproducibility and prove-out matrix that meets the standards before it moves to the precision matrix. So overall, I hope the goal was not to just demonstrate the intimate details about the Chrysler oxidation deposit test, but you also got a snapshot of what it takes typically for some of these engine test developments to go through these stringent requirements before it comes and it gets adopted in the specification. And again, as I said, it's an exciting time to be in this industry, because if I look at the upcoming GF6 category, there's a lot of new tests, either through engine replacement or through newer performance that would keep us challenging. So with that, I would like to thank you again for being patient and listening to my talk. Thank you.